video we're going to be looking at how to hook up the PMB248 GPS receiver to an Arduino, and we'll also look at the code that is required to get these things talking. Now, the GPS receiver here is very easy to use, and it's pretty inexpensive actually, and I'll leave a link in the sidebar to where you can get this. So let's talk about what these wires all do on the side of it. Now the first two wires off of it are for RS-232 communication, which we won't use. We don't need them. We need TTL logic. The next wires, the black and red, are for power, and the yellow and blue are for the TTL serial communication, which we do need, but we do not need the blue wire, which is for receiving serial data. So basically, to hook this thing up, you only need 3 wires. So let's go ahead and do that. So we hook up red to our 5 volts, then we hook up our black to our ground, and you'd probably want to use a breadboard to do this because these wires are so skinny. See, there we go, they fall right out. And we're going to hook this thing up to our, there it goes again. We're going to hook this thing up to our software serial library, which means you can use any of these digital pins as a serial communication pin. So we're going to hook that up to digital pin 2, because I want to use our hardware serial communication pins to talk from the Arduino to the computer. So this is how the communication scheme will work. GPS to the Arduino, then the Arduino to the computer via the FTDI USB serial converter chip here. So that's the hookup. That's all you need. Let me double check that. 5 volts ground and yellow. So when you put power on this thing, I don't know if I have a, here we go. So when you put power on this thing, you'll notice, do I have that right? This thing has a built-in LED on it. You see that? And when it blinks, that means it's searching for satellites. And when it's steady, that means it's locked onto satellites. And I think it needs at least 3 satellites to lock on. I'm not sure. But anyways, let's take a look at what's going on in the computer now. Alright, so now that you have your GPS hooked up to your Arduino, we can look at a couple things on the computer here. So here is the website where I bought the GPS from. This is the one from Parallax. It's not made by Parallax, but they sell it. It's the PMB248. Now, a couple things to look at when you're looking at buying your GPS. And let's zoom in here. You always want to take a look at how many satellites it can lock onto at once. And this is usually referred to as the number of channels. This one can lock on at 12, which isn't great, but it'll do, and it will lock on pretty somewhat accurately. The other thing you want to look at is how it communicates with the microcontroller. And obviously, you'd probably want to use serial communication, but you need to make sure that it's TTL communication, which means transistor to transistor logic. And down here it tells you that, again over there, and it also tells you the speed. And transistor to transistor logic just means that it's 0 to 5 volts or 0 to 3.3 volts. There's no negative numbers. And your microcontroller would have no problem reading it at 4800 bits per second. So also this one has a built-in rechargeable battery so that you can always check the time. Because in case you lose satellite communication, you'll still have your time stored, which is kind of nice, I guess. And it kind of goes over a couple other things. But oh, there's the price. This thing is a whopping 25 bucks, so that's kind of the reasons I bought it. Don't have a purpose for it yet, but it's certainly reasonable in price. Alright, so let's take a look at the code. We're dealing with the Arduino, obviously, and this is the IDE. So the first thing we're going to do is include a library. And we're going to use the software serial library. Off that yellow wire was the GPS's TX pin. So we need to make our RX pin 2, so it receives that data. And if you don't know what software serial means, that basically just means that you can turn any of your digital pins into a serial connection with a device, which is very handy because the Arduino only has one UART, or serial communication pins, 0 and 1. Anyways, let's move along here and get into the setup now. This is a very simple program. Let's go ahead and start the software serial, which is simply renamed it GPS. So GPS.begin at 4800 bits per second as specified by the device, as I just showed you. Okay, now we'll do a serial begin because I want to communicate with the computer at 9600 bits per second. Alright, and that's it. So now we can go ahead and start the loop. Alright, and now this is very, very, very simple. Now the GPS is going to put out one byte for every piece of data it gets, and I'll explain that in a second. But so when we read, let's go ahead and paste that over. So this will read from that pin 2 that's coming in at 4800 bits per second, but it's going to be coming in at a byte per second. Like we're going to get not a byte per second, but we're going to get a byte and not like a number. So you have to actually tell the Arduino that it's coming in as a byte by doing that, and then when we print it back to the computer, it will translate that byte into an ASCII character that we want. We don't want it to come in as gibberish, hexadecimal numbers that mean nothing to us. And that's pretty much it. We'll close the bracket, and that's it. So if we were to upload this, let's go ahead and try, make sure it works. Alright, it's uploading. Now this is just going to simply print out anything that's coming through that thing. We don't care what it is. And right now I don't have a lock, it's blinking, but let's see what we got here. Alright, I open up the serial, the terminal there, and here it comes in. Now this might not look like a lot to you, but it's coming in perfectly. You need to look for these sentences, as they call them, and you'll see a $GP and then 3 characters. The GGA, the RMC, whatever, blah 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 blah. Whatever this means. Might not mean anything to you, but after you do a Google search for NMEA data or sentences, you can come across a page like this. And you click the NMEA sentences, and they give you a breakdown of what they are. And then, as I showed you, they start out with that $GP, but then there's 3 characters, and that's what all these are. So I saw one that said, let's see, we had one that said GGA. I know I saw that one. Let's see if I can stop it here. GGA, there it is. So then it breaks down, and there it is. The exact same sentence that we just saw in my data coming in. So what this website does for you is tell you exactly what all of this data means and how do you decrypt it or decode it. And it tells you the time, then it tells you the latitude, the longitude, then it tells you its fixed quality, which basically is it on or off or whatever. This will either be a 0 or a 1. It tells you the number of satellites you have. It tells you some other stuff that, whatever you might not know. You might get your altitude, and depending on your GPS receiver, you might have more than one sense. See, I'm getting GGA, I've got the RMCA, I've got GSA, GSV, just a bunch of crap, and it really depends on the brand of your GPS because you might get more or less. Here's the GSA one. Some of these will tell you, oh, here's the RMC one. That's the one I use for one of my projects because it tells you your speed in knots, which is kind of handy. Yeah, same thing. Your latitude, longitude, Also, I like to read this active or void character here that you'll see down here. Comes in handy, all of this. But that's pretty much it. So check it out. You know, it's at this point it's so inexpensive, you might as well slap a GPS on any one of your projects. And thanks for watching. That's the PMB 248.